Hi, I'm Baymax. Today, we'll talk about variations. In dealing with this lesson, you should remember these words: quantities and predictable change. Note that if there are two quantities that has predictable change, then it is a variation. There are different kinds of variation. We have direct variation, inverse variation, joint variation, and combined variation. These are the kinds of variation. Our first lesson is about direct variation. Direct variation has two types: direct linear variation and direct square variation. Now we'll focus first on direct linear variation. This type of direct variation has a formula of y equals kx, in which x is independent and y is dependent. To know if the equation is a direct linear variation, we should remember these lines. Y varies directly with x and y is directly proportional to x. For example, find the constant of variation in the equation in which y varies directly as x and y is equal to 51 and x is equal to 3. So your hint that it is a direct linear variation is the line y varies directly as x. So the equation goes like this: y is equal to kx. And we'll substitute the values in which y is equal to 51 and x equal to 3. Then we will have to interchange them, and it will be like this. And we'll divide both sides by 3, and the result would be k equals 17. K equals 17 is a constant of variation, and y equals 17x is the equation of variation.
Hi, I'm Dora, and I'll be teaching direct square variation. Square variation has a formula of y is equal to kx squared. The process of looking for the value of the constant of variation, which is the k, is still the same in the linear variation, but the x must be squared this time. To know that it is a square of variation, we need to familiarize this line. Y varies directly to the square of x. For example, give the constant of variation in which y varies directly to the square of x and y is equal to 200 and x is equal to 5. Note that the line y varies directly to the square of x is there. So the problem is an example of direct square variation. Now let's solve. Y is equal to kx squared. So let's substitute the values. So y is equal to 200, and then to the other side, k times 5 since x is equal to 5, and then raise it to the second power. Then simplify it. So it will become 200 is equal to k times 25. Multiply 25 by k, so it will become 25k. And then interchange it so that it will become 25k is equal to 200. Divide both sides by 25, then k is equal to 8. So our constant of variation here is 8.
Hello there, I'm Joy, and I'm gonna teach you about inverse variation. Remember, in direct variation, y is dependent to x. If x increases, y increases. And if x decreases, y decreases. The formula of inverse variation is y is equals to k over x, in which y varies inversely as x, or y is inversely proportional to x. Example, if y varies as x and y is equals to 1/3 when x is equals to 18, find y when x is 2. The solution goes like this. Y is kx. 1/3 is equals to k over 18. Multiply both sides by the denominator, which is 18, which results to k is equals to 18 over 3. Then k equals 6. Now let's solve for y when x is 2. Y is kx, y is equals to 6 over 2, then y is 3. Thus, y is 3 when x is 2. In inverse variation, as x increases in value, y decreases.
Guten Tag, Alice. In English, good day, everyone. Our lesson for today is joint variation. Joint variation is way different from your past lessons. This time, you're going to deal with 4 variables. This time, one variable varies on 2 other variables. The formula is y is equal to kxz. To classify if it is a joint variation, we should familiarize this line. Y varies jointly as x and z. For example, find an equation of variation in which y varies jointly as x and z, and y is equal to 45 when x is equal to 18 and z is equal to 10. Find y when x is equal to 20 and z is equal to 30. Now let's go to the solution. The equation is y is equal to kxz. We will substitute the values in which y is equal to 45, x is equal to 18, and z is equal to 10, and get the product of x and z. After getting the product, we will interchange them and it would be like this. Then divide both sides by 180. Then we will get the constant variation, which is k is equal to 1/4, and the equation of variation, which is equal to y is equal to 1/4 xz. Let's solve for y. Since we already found out the value of k, we can now solve for y. Substitute the values in which k is equal to 1/4, x is equal to 20, and z is equal to 30. Then multiply x and z. After getting the product, multiply the product of x and z to k. So it would be 600 times 1/4, or 600 divided by 4. Then the result would be y is equal to 150. Thus, y is equal to 150 when x is equal to 20 and z is equal to 30.
Good morning, everyone. Now, we will talk all about
Combined variation. Yes, and the formula of this is y is equal to kx over z.
to determine if the problem is an example of combined variation. We should familiarize this line.
Y varies directly as x and inversely as z.
The process in solving this is the same as inverse variation. But this time, you already have 2 numerators and a denominator. K and x as numerator and z as denominator. For example, find the equation of combined variation where y varies directly as x and inversely as z. One set of values are y is equal to 4, x is equal to 6, and z is equal to 3. Find y when x is equal to 15 and z is equal to 10. The solution goes like this. Y is equal to kx over z. 4 is equal to k times 6 over 3. Multiply both sides to 3 to cancel the denominator. Then it will be 12 is equal to k times 6. Then it will be 6k is equal to 12. Then interchange both sides and divide both sides by 6. So your constant of variation is 2. And the equation of variation is y is equal to 2x over z.
Next is let's solve for y. Y is equal to 2 times 15 over 10. Then it will become y is equal to 30 over 10. We got 30 because we multiply 2 and 15. Then next is simplify 30 over 10. Then the answer will be y is equal to 3. Thus, y is equal to 3 when x is equal to 15 and z is equal to
Video 1.